Hello everyone, welcome to Civil Engineering and Stuff, and today's topic of discussion is quality of irrigation water. And in this video lecture, we are going to discuss about the variety of impurities that are present in the water, and if this water is used for the irrigation purposes, what they will do to the yield of the crop or to the growth of the plant. And we are going to discuss about the various methods in which these impurities are found, and in some cases how these are countered. So let us start with the basic introduction. So we know that if the water that is used for the irrigation purposes carries higher amount of impurities, that will have a derogatory impact on the growth of the plant. That water will be injurious to the growth of the plant. And on and all, the quality of the water is dependent upon the soil. The reason for this is, suppose we have a crop that requires irrigation, the water from the source will be transported to the field through various channels. Now, as the water is being transported, it will carry few of the sediments with it, the soil particles with it, and depending upon the type of sediment that is the water is carrying and the concentration of variety of nutrients in these sediments. So when these sediments are reached to the field, they start getting accumulated along with the water. Some are absorbed, some stay on the surface, and they will, to a certain extent, will contribute toward the overall nutrients of the field. And likewise, the nutrient content of that are present in the in situ soil, that is there in the field, will also contribute towards the overall change in the nutrients. Right. So on and on, the soil plays a very important role in the quality of the water. In this lecture, we are going to discuss about the various type of impurities, that is the total sediment concentration in the water, concentration of soluble salts in the water, proportion of sodium ions with respect to the other cations, and the presence of toxic element in the water. And after this, we are going to discuss about the bicarbonate concentration related to the concentration of calcium and magnesium. And at the end, we are going to discuss about the bacterial contamination in the water and what is its impact when it's used for the irrigation purposes. So let us start with our first subtopic, that is the concentration of sediments in the water. Now, the concentration of sediment depends upon the land that is used for the irrigation purposes, and if the concentration of the sediments is more of a sandy soil, then these sediments will improve the fertility of the soil. While if these concentration of these sediments are more of a eroded soil, then they will reduce the fertility. Here, the eroded soil, what do we mean by the eroded soil? Eroded soil, we mean that the water is carrying with it lot of pebbles, lot of stones. And when these pebbles and stones are transported to the field, so upon their accumulation, the uniform distribution of the water across the field might not take place. The amount of nutrients that the crop need to absorb, these eroded particles will hinder those processes, right? So that is why if the concentration of eroded soil particles are there in the water that is to be used for the irrigation, then they will reduce the fertility of soil. While if the concentration of sediments is more of like sandy soil, then they will improve the fertility of the soil. Next, we have the concentration of soluble salts. Now, salts like calcium, magnesium, sodium and potassium, if these salts are present within their permissible limits, they will contribute towards the growth of the plant, or they will contribute towards the yield of the crop. However, if the concentration of these salts is in excess, then they will reduce the osmoticity, they will prevent the aeration process, and they will cause serious injuries to the plant, and they will deprecate the overall yield of the crop. These concentration of these individual salts are measured in ppm or milligram per liter. Now, the salinity concentration of the soil is found by this formula. Here, the salinity concentration, we mean that the combined salt concentration of the land. So we are not talking about the individual elements here. We are talking about the combined salt concentration, combined salt concentration of the land. Now this is found using the formula CQ divided by Q minus Cu minus P effective, where C is the concentration of the salt in the water to be used for the irrigation purposes. Q is the quantity of the water that has been applied, right? So C is the how much quantity of this overall quantity of the salt that is present in the water. Combining those, these C and Q will give us a parameter called as the total salt applied to soil with Q amount of irrigation water, right? Individually, this is the meaning, and combined is the total salt concentration that has been applied when we apply Q amount of water for the irrigation purposes. Here, Cu is the total amount of water used for the plant for their growth, right? And P effective is the useful rainfall. So, subtracting the Cu minus P effective will give us the water that has been used for the irrigation, right? So, through this we find out the overall salt concentration. Now, the salt concentration is measured by the assessing the electrical conductivity of the water, and it is expressed as micromole per centimeter. And based upon the electrical conductivity of the water measured at 25 degrees Celsius, we have different ranges to quantify if this water is is suitable for the irrigation purpose or not. So if we have the conductivity in between 100 to 750, conventionally the water is fit for the irrigation purposes, and 100 to 250 means it's perfectly good water. We have a very low concentration of saline. 250 to 750 we have a medium concentration of saline and need to be observed regularly so that further impurities don't add up, increase the salinity of the water. However, both can be up to 100 to 750 range, both this range, for if the concentration is in between this, it is fit for the water is fit for the irrigation purposes. Now, higher than 750, that is 750 to 2250 micromoles per centimeter, the water is categorized as a very high saline concentration, and this is not used for the irrigation purposes, especially in the areas where there is no drainage provision, right? Where there is no drainage provision, we will not use the water that has this much amount of conductivity. And if it is higher than 2250, then this water is completely not suitable for any type of irrigation, irrespective of what the condition is. So proper treatment has to be given if this water has to be used. If we use this kind of water for the irrigation purpose, it can be said with certainty that our plant will die or the yield of the crop will be totally degraded. Next parameter is the proportion of sodium ion to the other cation ion. Now, in generally, if like the permissible limit is 5%, if we have till 5%, like 5% or less, then the concentration is considered to be the ideal, and like it will contribute towards the overall growth of the plant. If this concentration is between 5 to 10, things can be managed. But if the concentration goes above 10%, then what will happen is the breaking of the soil particles will take place, and the soil will become less permeable, pH will increase towards the alkaline soil, and eventually the water as well as the land in which this water has been used will be unfit for the irrigation or unfit for the growth of the plants or the crops. Now this is measured using what we call as a factor called as sodium absorption ratio, and is measured by the equivalent per million. The sodium absorption ratio is found out by the formula Na plus divided by under root of Ca2 plus Ca2 plus ion plus Mg2 plus ion divided by 2. This is the formula to find out the sodium absorption ratio. Now again we have certain range for SAR value. So if we have 0 to 10, then we have low sodium water and can be used for the irrigation purposes. 10 to 18 and 18 to 26 categorized as medium and high SAR concentration respectively, and generally treatment is required. So what kind of treatment shall be given? So if this type of treatment is this kind of SCR value is there, then we have to add some to the soil to bring down the SCR value, and then the irrigation and cultivation can be done. If the concentration of or the SCR value is higher than 26, then it's deemed to be very high, like no cultivation can be done. The next point or next impurity is the concentration of toxic elements in the water. So in this toxic element we have first is the boron, and traces of boron is very important for the optimum growth of the plant. But if the concentration goes beyond 0.3 ppm, then the toxicity is way too high for the water to be used for the irrigation purposes. Likewise, no concentration of cerium should be there in the water, as it is very toxic and will degrade or lead to the death of the crop. Right? These normally comes because of the addition of too much fertilizers uh, into the crop during the cultivation process, and when we use this kind of uh, fertilizers, and when the irrigation done, the water absorbs these and take them to the root level and will lead to the degradation of the crops or like death of the plants. Next point is the bicarbonate concentration, and basically if we have high concentration of bicarbonate, this will result in the precipitation of calcium and magnesium carbonate, and this will increase the overall proportion of sodium ions, causing like the sodium hazard, like what we have discussed in the SAR. The last point is the bacterial contamination, and conventionally bacterial contamination is not a serious problem, and to a certain extent they contribute toward the healthy crop. But if the water, like if you use sewage water for the irrigation processes, there the concentration of bacteria is way too high, right? And in that case, this will lead to the overall depletion of the growth of the plants or death of the crop, right? So it is until unless we are not using some contaminated water, everything is fine. We don't need to care much about it. Okay, so these are the 6 parameters that are used to assess the quality of the water. So I hope the lecture was useful to you, and if so, do like the video, and do share your comments in the comment section, and if there's any topic of which you want me to prepare the lecture for. Right, thank you for watching, and I hope the lecture was useful to you. Please like, comment, share, and subscribe to the channel. Thank you for watching. Have a nice day.